Next up, we have the watch window. After loading it, let's dock it to the bottom right, underneath the code window, but to the right of the immediate window. Again, be patient, this can be a bit fiddly, but it's definitely possible. What does this window do? Well, so far we've seen 3 ways we can enter break mode: by interrupting a procedure underway using the escape key, by stepping into a procedure from the very start by keying F8, and by placing breakpoints on the lines we want to start stepping through from in the procedure. Now, imagine you have a long and complex procedure. You run it and find that it sometimes works, but sometimes does not. When the procedure doesn't work, the error always occurs on a certain line. But because the procedure works sometimes, putting a breakpoint on that line may not be very helpful, since you may enter break mode even when the error is not going to occur. This is where the watch window comes to the rescue. Instead of your entry into break mode depending on a particular line in the procedure, you can instruct the IDE to enter break mode when a particular condition is true. When you set up such a watch, you can really save yourself lots of time because you only enter into break mode at the exact instance when the conditions which lead to your error arise. Let's see how to set this up with a specific example, which will also serve as a mini debugging exercise. Imagine you need to calculate the following numerical series, where each iteration of I and j are described by the following relations, and the starting values are as follows. Let's start by declaring our sub with the name math series. We next declare I, j, and c. Let's stop a moment to think here. If you look at our starting values and the way they are transformed, these variables are only going to be handling integer values. Integers take up less memory and are quicker to handle than decimal numbers. So let's restrict the data type to some kind of integer. Now, as a technical aside, VBA has 2 integer types: the standard integer and the long integer. This follows conventions which were established long before VBA came along. Unfortunately, it turns out to be the case that this is the only time when a data type that uses less memory is handled more slowly than one that uses more. The time difference involved is negligible, but unfortunately, programming turns you into a very, very fussy person. And I say fussy for lack of a ruder word. All this is just to say that you'll see me declare all my integer variables in this course as long integer types, and you're welcome to join in too, though using standard integer types won't kill you either. Aside, over. To declare I, j, and c as integers, we use the following statements. Next, we need to declare q. For this, we can use a double precision floating number, which is the number data type which offers the highest decimal precision. The keyword for this data type is simply double. Now, let's initialize the values of these variables as per the information we were given. As written, this code will only pass through one iteration. For it to generate our series, the steps have to be repeated. The simplest way to do this is to use a do loop control statement. Just before the arithmetical operations start, we add the keyword do. Just after the end of these operations, where we would want the code to repeat, we add the keyword loop. We can indent our code using the tab key, making clear it's all part of this do loop here. And it's that simple. The only problem now is that this would carry on looping forever. Let's use a counter variable to help us out. Let's set its starting value to 0. Next, we add c plus c plus 1 inside the loop block, and this means that c counts up 1 with each loop, as I and j do. Now, at the start of the loop, let's add the condition. If c is greater than or equal to 10, then exit do. That's also pretty easy to make sense of. As soon as we have looped 10 times, the application will stop the looping process and continue on to the next line after the loop block. Great. We're ready to execute in run mode. Hit F5, and we run into an error. We're told it's because of a divide by 0 operation. And of course, that's exactly what I set up this problem to do. Let's select End and return to Edit mode for now. Now you've seen we've made this code really simple so that it's obvious what's going on. But imagine we're dealing with a much more complex problem where we do not understand what's happening. In such cases, to learn about what needs to be changed, we could find it helpful to walk through the code step by step. We can do that, of course, by running the sub in break mode from the very start. But we are given a head start on where the error occurs, as we just saw. So we will often feel comfortable cutting to the chase by placing a breakpoint directly on the line where the error occurs. And we do that here by clicking on the line and keying F9. In a larger procedure with many preceding steps, that definitely saves us time over stepping through from the very beginning. And while this could help us fix the problem, you'll see that it's a really inefficient approach for this particular case. The breakpoint makes us stop on that line every single loop, not just on the loop where our problem occurs. With that in mind, you may appreciate that breakpoints are also inefficient here because they only stop on the line where the error is raised, and not the point in the procedure where the conditions creating that error first occur. You may have to invest more time sleuthing the problem because you then have to work out where the problematic conditions which create this error first arise. Debugging the code using a breakpoint in this case wastes time. Imagine instead that you do understand that the error is caused by the event I plus j equals 0, but that we don't understand when I plus j equals 0 occurs. In long and complex procedures, it's very possible that the conditions which lead to an error originate a long way from the statement which finally raises that error. But now we'll see how we can use watches to overcome these limitations by only entering break mode at the very specific moment when those conditions have occurred. So let's create a watch to monitor the condition I plus j equals 0. We can type that into the immediate window, highlight it, then use the shortcut Shift plus F9. This opens the Quick Watch window, submitting the highlighted text as watch. Note that this also works if you type the statement in the main code window. Now we select Add, and that watch has now popped into the Watches window. Our next step is to right-click on that watch. A menu pops up. You'll see it's possible to add the watch here directly if you don't want to use the Shift plus F9 method. You'll have to type the watch statement in the text box there provided. Note that you can delete the watch from here as well. Right now, though, we just want to edit the watch we've loaded, so let's click on that option. Let's look at these options listed in the section labeled Watch Type. The first one here just allows us to monitor the value of our watch expression, much the same as we would do using the Locals window. The only advantage the watch has over the Locals window for this feature is that we can monitor combined variable states, like we have here with I plus j equals 0, without having to create a dedicated local variable to be able to view that through the Locals window. The second option, though, is where it gets interesting. It says, break when value is true. This is what we're really looking for. By selecting this option, the IDE will enter break mode the very line after I plus j equals 0 occurs. In this case, you enter break mode anytime your watch expression changes value. This can be helpful if you have a variable that's normally constant but changes at some point, causing an error or some other outcome of interest. After you've made your choice, click OK. If we run the procedure now, bam! Indeed, it breaks at the precise instant that I plus j equals 0. Amazing, right? So is this watch tool the answer to all our debugging needs? No. If you stop to think about it, you'll appreciate that this watch tool is only useful in cases where we already have a certain amount of knowledge about the problem we're faced with, And even then, it's only of interest if the condition we're interested in is not tied to a specific line of code, which is often the case. In practice, it will be plain old breakpoints, debug.print, and message box commands, which will be doing much of the heavy lifting while you are debugging.